Hey, we're talking logarithmic functions. Logarithms are basically fancy exponents. So if you were solving 2 to the x equals 8, 2 to the what power would give you 8? Well, 2 to the first is 2, 2 to the second is 4. 4 times 2 would give us 8, so it's 2 to the third. So x equals 3. Oh, that was fun. Okay. Now, we're going to be going back and forth in exponential form and logarithmic form. So to write it in logarithmic form, if you look at the base one, it's always like our base to the exponent equals our answer. So if you look at how that's written in the logarithmic equation, it always starts out with log, but if you look down here, your tiny number right after the log is going to be the base. So if we were to do 2 to the 6th, our base is 2, so it would say log of 2, and then it goes right after that is the answer. So the answer here was 64, and it equals the exponent, which seems weird, and the exponent there was 6. So here's the way I remember it when I'm writing it from logarithmic form to exponential form. It's like a swooping arrow, so it's like 2 to the 6th power equals 64. So if I was doing that on this log 4 equals 1, I would say 4 to the first power equals 4. 4 to the first equals 4. So let's try that again on this. 5 to the 0 power equals 1. 5 to the 0 equals 1, which seems weird, but anything to the 0 power equals 1. Let me scoot down. 5 to the negative second equals 1 over 25. So we say log. And what's our base? Our base was the 5. Then we write our answer. The answer was 1 over 25 equals our exponent. And the exponent was negative 2. Great. It's going to seem weird at first, but you'll get used to the flow and the rhythm of it. So log, our base here is 3. Our answer is 81. And the exponent was x. Now eventually we'll be solving that for x, which would be 4, because 3 to the 4th is 81. So if we're swooping here, we'd say 10 to the second equals 100. 10 to the second power equals 100. Now, something you'll see eventually is you don't write the base of 10. It's kind of like, when you have x, it really means 1x. So this, you wouldn't write this like this anymore. You'd write log, and you would just leave that blank. 100 equals 2, and it means there's an invisible 10 down there. So that's going to be kind of a hard thing to get used to at first. 7 squared equals 49. So log, our base is 7, our answer was 49, equals our exponent 2. Our base is 5, our answer is 5, and our exponent was 1. And the last one, if you do the swoop, 12 to the 0 power equals 1. All right, let's see what else we got. Yes! Sure. So if you have log b of b, if it's the same number there, it's always going to equal 1. So if we have log 8 of 8, it's going to equal 1 because 8 to the first power equals 8. So if you ever had to evaluate it and it just said log 8, it's the same number, so you know it would equal 1. So if we have something equal to 0, that means the exponent is 0. So if it said log 9, and we said 1, and it said evaluate that, well, 9 to the what power equals 1. So anytime this number, the big number here, the answer is 1, then your exponent would be 0. So we are going to evaluate them here in a minute, and you'll see it's really not too bad. Sometimes we do have to, so look here, it says log 5 is really log base 10, 5. So they don't write the 10 usually. Yeah, there we go. So we're going to turn this into an exponential equation. So we're going to say log 216 equals x. And then we're going to set that up with exponents. So 2 to the x power equals 16. Now, me personally, I don't like to just guess and check. I like to, and I think it's helpful if you change 16 to the base of 2. Hey, oh yeah, that's right. How are you in the middle of something? Nope. Just record.